So hi everybody, let's continue our discussion on graphing absolute value functions. Now, from this time now, okay, if you will take a look, what can you see is different with this equation? And if you are going to compare it with our parent function, which is y is equal to the absolute value of x, okay? From the previous examples that we have mentioned, we were you will notice that you have your addition or you have your subtraction. So it was like this, right? If you are absolute value of x minus something, this is going to go downwards. If you have absolute value of x plus something, then it's going to go upwards. Now, if you're going to compare these equations to this one now, what can you notice? Okay, you will see that the plus sign here in our vertical translation, the plus sign is outside of the absolute value bars. Okay, now this time, as you can see, it is inside. Our plus number is together with our x inside our absolute value bars. So what does this mean? If you are adding or subtracting and those symbols are outside of your absolute value graph, you are moving your graph vertically, which means if you are adding or subtracting inside together with the absolute value inside the absolute value bar, it means that your graph now is going to move horizontally. Okay, so here now be very careful. Okay, when we had the vertical translation, you will notice that the sign according to the y-axis is exactly the same operation that you are seeing here. If it's going down, it's going to the negative values, it is minus. If it is going up, you're going to the positive values, you will see that it is addition. Now, the tricky part, and I would say tricky because a lot of kids always get this mixed up with, all right? If we are doing the horizontal movement, the signs are opposite, okay? So if you will see here, the minus sign is going to the right, okay? Do not contradict that one, all right? So just always remember, if it is the horizontal movement, it's the opposite side. So you know that on the right side, you have your positive numbers, but in the equation, it has to be minus. So if you see that it is plus, then it is going to the left. Okay, I need to emphasize this thing because again, these are one of the most common mistakes, especially when graphing. Okay, so if our equation y is equal to the absolute value of x plus 5, that's inside our absolute value, where are we going? Are we going up, down, left, or right? The plus sign is inside, so it's going to be a horizontal movement, and the plus simply going to the left. Okay, so we move our vertex 5 to the left, so it's going to be here. Sorry, it's going to be here. And so your points for the absolute value, again, it's always just diagonal on both sides, all right? So that is how your graph would look like, all right? So why don't you try this next example on your own? Go ahead, graph this absolute value function. All right, so remember absolute value of x, this is how your parent function looks like. The up or down movement, the addition, subtraction is outside. The left and right movement, it's going to be inside together with x in the absolute value symbol. So here we have x, the absolute value of x minus 5. So it means it's going to be moving to the right, and so our graph will look like this. Okay? So now let me introduce to you some more graphs. So as you can see here, we have two other graphs. And these are two different functions, okay? So this first graph is what we call as a piecewise function. Piecewise. What you can remember here is that certain parts of the graph will have different rules when it comes to its domain. So if you will take a look, this part of the function, this part of the graph, it has a domain x values that are less than 0. All right, those are the domain here will always be a negative value, although the function is the absolute value of x. All right, on this side of the absolute value function, you will see that all the x values will be positive, but as you can see, absolute value of x will still be positive value. All right, so you will see that you have different sources, different ranges here for your you have different function rules based on your domain. All right, now what can you observe about this next function? As you can see, they look like ladder steps, correct? So it's like you are going up on steps. That is why this is what we call as the step function. So it is a function that pairs every number into an interval with just a single value. Okay, so from here, from -2 to positive, from -2 to -1, it is just this specific value. From -1 to 0, it is just this specific value. All right, so we have already discussed our absolute value function. So for this next part, we'll be working on an example for a step function, and how will you be able to look at that. All right, so the best example that we can think of would be, for example, having a school trip. And so we have a number of buses that can take the student. All right, so it says here that each bus can hold up to 60 students. So what will be the graph of this showing? So the x is the number of students, and then y will be the number of buses. All right, okay, so so let's label this values here. So x is our number of students. X is the number of students. And then y is our number of buses. All right, so if we have let's say this is 30, this is 60, 120, 180. Okay, if you have all right, let's have this as 1 bus, 2, 3, 4, and so on and so forth. Okay, so if you have 1 student included in the trip, how many buses do you need? 1 student could be placed in 1 bus, right? So you can have, my bad. Okay, 0 students, do you have number of buses? No. So 0 will be a hollow dot because 0 is not going to be included. The moment that you use 1 bus, you need to have at least 1 student, correct? If you have 20 students, how many buses do you need? It's still 1, all right? Actually, 1 bus, as mentioned here, can hold up to 60 students. So if you have 60, how many buses do you need? Just 1, okay? So 60 is going to be a solid dot, and it simply means that from 1 student up to 60, only 1 bus is needed. All right, now the moment that you hit 61 students, how many buses will you need now? You can you need to have 2, because you cannot put all the kids, because the maximum capacity of 1 bus is just 60. So the moment that you have a 61, it's gonna be 2 buses now. So 60, just like what we did here with 0, will be a hollow dot, and 61 up to how many students? Up to 120 kids, it's gonna need 2 buses. Okay, you cannot have like 2.5. You cannot cut the bus into 2. All right, so if you have 121 kids, how many do you need? You're gonna need 3 now. Okay, so a hollow dot, and then until you get 180 kids, you can use 3 buses. So this is how your step function looks like. All right, it is based on the context of our problem. You cannot have like something that is like the absolute value where it is a continuous line. All right, because there are specific y values alone that could accommodate this number of students. Okay, and so to summarize the lesson, you can quickly graph your absolute value by shifting the graph. You can move up, down, left, or right of the absolute value of x. Thank you.